Hello, Natroners, and welcome back to another episode of VFX with Natron. So, last time we sort of finished up character animation or puppet animation, and I wanted to just, we had a small problem at the end where Natron acted a wee bit weird. And then I was like, oh, well, I couldn't figure out why Natron was acting the way it was. But I wanted, before we go into today's topic, which, by the way, is magnetic field distortion. I do want to quickly, and I'm not going to show a preview of it because it's not really. This isn't a very, very long episode in that sense. So I'm going to just go back and bring up last week's thing just for a second. So I'm going to hop over into Natron and let's just take a look. Let's go over here, and we can see this is where we left off, or sort of, except for with the difference that I went in. Oops! If I pull up, if I pull up the node for the character, and we selected all. There we go, and selected all. You can see that that all the channels have been basically selected. All I did is I clicked on each one of the individual channels that needed to be looped. Let's find one that actually has something that was looped. I clicked on it so that it was highlighted. You can see this is green currently. Let's find one that's a nicer color, an easier color to see. Huh. Oh, that's not one. Here we go. So this is purple, and we can see that when all you had to do to select them was all you did is you clicked on. All right, Natron's not going to let me do it. Oh, right, you can't select, you have to select the actual waveform inside of the animated range, which was very short, which was in the first 25 frames. So I select it here where, oh, come on. Natron, do it. Select, there we go. So it selects it, it's yellow, and once you have it yellow, if you right click on it and you go down to predefine, there's this option to loop, and then you can set it to, you say 1 to 24. And that's all we did on all the stuff. But the problem we ran into was, of course, that I ran into a problem that I had a crop node originally in this that came after the character node before this node down here, and I was in such a rush that I forgot I even had this here. Which I had put in there intentionally on the files that you all downloaded. So I had eliminated the animation out of this and reproduced it in another thing, and or in a separate node, and we ran into all kinds of issues. It didn't want to work. It didn't want to update. I just wanted to quickly show that it was fixed. All I did, other than this is the only thing I wanted to point out. This is how it should work. I retested the other thing after I got off, and all I can say is that obviously there was some conflict when I restarted Natron. It made it work. So I just want to show you guys quickly that up here you can see that we have the character animation, and if we go into the curves and look at the actual character itself, you can see that I'll have on the character, at the actual character translate, I'll have the node moving, and it's moving in a linear form. All I did is I told it that I wanted for this one, I changed the interpolation to capital ROM, which basically makes it continue on in the directions. As long as it's a linear movement, you can use capital ROM as opposed to having to loop it. But the key thing was that I was running into a problem with was that when we couldn't offset it with the second node. We had a second translate node that was supposed to offset it off screen, and when we did, for some reason the character just disappeared off into nowhere, and I checked everything else. I have no idea why it didn't work. I have a feeling I must have hit a key or something that just disabled something, and I couldn't find it, because when I rebuilt those same nodes, it worked fine. And I want to just point out that we can see here, I've got it positioned at negative 240. And if we play it from there, we can see that the character indeed steps into the frame and he's there. So, and this is the animation we did over the course of Saturday. And you can see it has all the things. Everything is working. All it is it's looped. And we have the two things there. We have this offset by negative 240. and we had this set, which we had done in 2 extra nodes that came after these nodes. And I'll have a feeling, and there was also a crop node in here as well. I got rid of the crop node. It was a cleanup thing. It wasn't really needed. Actually, I think I put the crop node, I moved the crop node down to here after our background so that it became the size. I just set it to the size of our output, and that's it. That's all I wanted to go into. It works now, as you can see, and it moves. If we scrub across, we can see it moves all the way across in the 400 frames, and it works. You can download this project. It's still there. It has all the notes and everything, and you can download it before this animation, or before it was animated, and after. And I also included the 4th of July one, so you can see the original one, because the animation was a little sloppier, and I didn't take as much time with it. Anyway, because I tried to rush it. Anyway, we're going to discard that because that's not today's topic. Today's topic, we're talking about warp field. Or we're not warp field. What we're doing is, I've brought up a warp field here. We already gone over warp field distortion to a degree. There's something we need to know about warp field. Now, warp fields are made up of basically 3 things. We have a background which is solid. The reason it's solid is we don't want an alpha channel by default with it, and it starts off with black, and then we add a radial over it, or some shape over it, and that shape that we put over it has a color, and that color dictates the direction that the warp is going to happen on, because as we know, the iDistort node works off of UV. And UV is determined by the first 2 things, red channel and the green channel. And it's how those 2 channels combine determine the direction that the warp is going to happen. So as we can see here on the red channel, we have 0.5 and the green channel has 0.5. And that sets up the initial direction of the warp, which in this case is going to be a 45-degree angle, because it's halfway between it, or it's equal amounts of both. So that's going to make it basically move from here, because it works from the brighter it gets, the more it distorts towards something, and the darker it is. If we went into negatives, it goes in base. It will. What will happen is, as stuff comes towards the center point, it gets pulled from here towards this, and likewise from the opposite direction it gets pulled in this direction. So here it's stretched in this direction. If it's moving in this direction, it stretches as things as they come towards this transition point, the 45-degree mark, and then it pushes away as it gets away. And the reason it looks smooth is because, well, we have a nice gradient on it because it's smooth here. All right, and then what we did to this is, because we want it to be visible both in the positive and the negative directions, we added 0.5 to it, so that we start off at the 50% gray. So we add 50%, and that's why our yellow was only taken up to 0.5. That way, if we go into we could go into a negative. If we take this down into the negatives to negative 0.5 in both directions, we can still visibly see that, but this is negative, which means, and we can see it here, whereas if we had looked at it here without adding that add node, we just see black, so it's not very visually informative. But we can see here, we see blue, so that means it's going to push in the opposite direction. This is opposite to yellow, which is going to push it in diagonally towards this corner. And so if we actually go to our iDistort, when we look, we can see it. Now, if we go to, I'm bringing up this because what we're going to be doing today is going to warp in a very different way than this. One of the things that we may not be realizing is that this is a linear warp. Everything is moving in a constant direction. The only reason it tapers off is because of the gradient, because we're dealing with something smooth. However, if we take the smoothness of let's actually go to our add node. If we go here and we look at the smoothness of our radial, and we drop this rate down a bit so that it's not as smooth, so it actually has a plateau, so to speak. It gets up to that blue quicker. It's going to make a plateau where everything in that plateau moves in the same direction consistently. And that could be, you might find some use for that. It's a bit odd. So let's see, right now, as we can see, it's shifted everything towards, diagonally up towards the corners, but it's pulled it away from where it was, and you can see it transitions, so we wind up with this stretchy bit. But that can be useful, but it's a clear square distortion, all right? And it's a clear distortion going in a single direction, in that way, and that's useful. That's useful. But the real problem we face, of course, is that as you can say, as we flatten this out towards the smoothness of 1, it's still pulling linearly. All the points along this are moving in a single direction. Everything, all of these points, even at the smallest point, they're moving in one direction, and sometimes that's not exactly what you want. You may not want it to move linearly. Sometimes people want the things to pull towards this center point or push away from that, and that would be called a magnetic point. We want this to act like a magnet. So how might we make something that is magnetic, so to speak? I've moved my warp field off to the side, and now we're going to actually have to talk about, we already know that if we look at this is a grayscale. We're dealing with something that's at 50% gray, and the reason that nothing moves, if we look back at our distortion, the reason that none of this outside texture moves from the original texture, which is here, this is the original, our checkerboard, and this is our eye distort, and the reason nothing but the area that got distorted moves is because back here gray is at 50% or 0.5, and if we look at our eye distort here, we see that our UV offset is set to 0.5. So that means that as long as everything happens at 0.5, and by the way, every type of distortion we're going to be using, we're always going to be setting the eye distort nodes offsets to 0.5. Even today's, we're going to be doing that. All right. But this is consistent, so it's not doing anything, different with it. It's not changing it in any way. So what we're going to be doing today is we're going to work with, we're going to be taking something a little different. We're going to take and we're going to create a UV map that, I'm trying to think of the best way of describing this. All right, let's start off with the obvious. We want to, one of the things we want to do is, right now, the reason that this is not moving or transforming in around that point is because it's a solid color. In order to make it sort of distort towards and away from that, what we need to do is put in UV coordinates relative to the center point of this radial. So let's just, for the sake of this, let's copy our radial over here. So we have a copy of it, and let's check our radial, and we're also going to remove source layer. We're going to say none, and we're going to change it so that we're going to reset this to default, all right, which is going to make it white. All right, now what we want to do is use this as we can see, this has an ROD to it. This is the bottom left corner, this is the upper right, this is an ROD. So what we'd like to do is make a gradient that works in the U direction, which goes across, the horizontal across, and the vertical going up, and across this entire space, the shape of this. And the way we're going to do that is we're going to use the SE EXPR node. So we're going to hit tab and we're going to type in SE. Whoop, Why did that not work? Oh, that was weird. Discard. Let's try that again. Tab key. There we go. SEEX. And we want the SEEXPR. All right. So before we do that, let's just look at, actually, let's just look at what happens. So the SEEXPR, we went over it before. To create a color, you need to put a vector inside of a color, something that defines colors in 3 variables, R, G, and B, between a value of 0 and 1 inside of a set of brackets. So if I put 2 brackets here and I put 1, 1, 1, that gives us white when we move our mouse outside of here. Well, inside, if we set it to 1, 1, 0, we wind up with our yellow. All right. So this is the red channel, the green channel, and the blue channel. So what we want to do here is we want to look at special coordinates inside of SEEXPR. We want to look at U and V. All right, and what U does, let's first look at U. Let's replace U in all of these for right now, so we can see what happens. So when we put in U, we can see we wind up with this gradient that goes from the left side of the screen to the right side of the screen. And that's what's happening is it's saying, I want to increase this from 0 to 1 as I go from the left side of the screen, which is 0, to the right side of the screen. Likewise, if I tell it I want to do V here in all of these, I go from the bottom of the screen to the top of the screen. So all we have to do to get this, to get our gradient from one side of the screen to the other side of the screen, is keep our blue 0 because we don't care about that, and put a U into our red, because that's the U channel, and a V into our green channel, and we should wind up with a UV map. And that is what this is. And people might have seen these types of maps before. These come around a lot in computer graphics, UV maps. They use them for texture coordinates and so forth. Anyway, they also use them for normal maps, for all kinds of things. Texture space, STM maps, which we'll get into STMs. Actually, pretty soon we're going to be talking about the STM node. I might talk about it a little bit more today. But anyway, one of the ways people see it is they either see it in this green, red, yellow form, or they see it where blue is 1, and they see it as cyan, magenta, blue, and white. And the only difference between the two is the blue channel, which is completely ignored. It means nothing because these are UV. They're just dealing with 2 dimensions. All right. So what happens if we take this and use this as our fundamental UV map for our eye distort? Let's take a look. Well, right now we can see that the whole thing went black. And the reason that it's gone black is because we don't have an alpha script inside of our SEEXPR. So we need to tell it that we want for right now, we're going to tell it we want the alpha to be 1. All right. And as soon as we do that, we see this. And what we notice is that what it's done is it's shrunk our texture relative to the coordinates. You'll see it looks like it zoomed it in a little bit. And the reason it looks like it zoomed it in is because we're doing this around this positional offset. Basically, it's looking at 50% gray, and everything from to the left of it, it's pulling towards the center point, the 50% mark, and everything from to the right of it, it's pulling towards the center mark. And everything on that's the red channel is doing that. All right. So if we look back here, if we go to R and we look at this, 50% is right here in the middle, right? So when we go back to this, if we think about it, 50% is here, So if this is a pull, it's pulling everything from here this way and everything from here this way, because we told the UV system that it's starting from the 50% mark, which is right here. All right. Likewise, if we go to the green channel, which is our V channel, and look at it, it's also set, the V is set to 0.5, which means that it's starting at the 50% mark. So everything from 0.5 is going to is based off of what this UV map is going to pull or push from it. So from down here, it's going to pull towards the center, and from up at the top, it's going to pull from that towards the center. And so what we ultimately wind up with is the entire image is getting pulled, and all that's happening on the edge is the edge colors are getting pulled towards it, because it's not told to be using black. If we tell it to be using black, we can see all it did is it pulled the entire image. It basically scaled the image. So what we've done is we've created a scale node. So what we really want to do here is do something more than this. Let's first of all get off the green channel so that we look back at this, and let's look at our SE expression node again. What we're going to do is take our radial that we have here, and we're going to use this as the bounds for this. UV don't have bounds. This is bound by default. What this is doing is this is looking at our rendered view, the polygon of our scene, but because it has no source. Well, sort of. It's actually because if we put it here, you can see as soon as I do that, as soon as I pipe the radial node, our distortion happens inside of the space that our radial node was. But the problem that we face is that this is overriding. We no longer have a circle. So what we wind up with when we get back to our radial or to our distortion here, let's turn off the black outside for this. Why is that not working? Oh, you know what it is? It's probably because there is nothing beyond the edge of this this distort. Right, we don't have UV coordinates, because we don't. If we actually look at this, if we look here, this is black. There's nothing, we don't have gray here. So what we would have to do here, let's put this back to, let's merge this over something. So we want to put this over a gray, very much like what we had before. Well, let's take copy our solid, but this time let's set our solid to 0.5, because we don't want to adjust this color. We want to keep this UV map what it was, but we want solid gray for the background. So what we need to do is look at our solid node, which is black, change this to 0.5, all right, which basically gets us to the same point here. And then we want to superimpose this over that. So that means we want to take a merge node, set to over, and take the result of this SE expression and put it over it. And now if we put that into the iDistort node, we should wind up, okay, we still have a problem. Let's see why we have a problem. Aha! The reason we have a problem here is because if we look at our merge node, there is no alpha, because the solid node doesn't generate an alpha by default, or at least the merge node doesn't recognize it. So we need to check this alpha box, and as soon as we do that, lo and behold, we wind up with our checkerboard, okay, but where this UV map exists, suddenly it is pinching and pulling around it to make this sort of distorted, scaled down version of everything around it. This is just a scaled down square of what our original texture is that was created by this iDistort. All right, so that's not overly useful, and And this is actually, we're not actually distorting in the same direction as we want to be too. This is actually, we're doing this in reverse, because one of the things, I'll shift back to the, all right, let's just shift back to this for a second. Let's go back to our warp field for a second and look at our radial colors for a second. Let's set our red to 0, all right, and our green to all right, let's just make this let's set our green to 1, all right. So we have something that's solid green here, all right. So we can see when we have a value of 1 here, and in our add node it looks like this, and when we get to our eye distort, what happens in our eye distort is a value of 1 makes the distortion go downwards, all right. Whereas or we should say, actually, it's technically, it should be a value of 0.5 makes it go downwards, but we've overdriven it to by a half a value, which Natron is not treating this as color information. It's treating it as non-color information, which is why it went beyond it. Anyway, so we can see that positive values, positive green values, make it move downwards. Negative green values, so when we go into a when we take this into a negative way, in a negative direction, so if we go to negative 0.5, it moves up, which means that this radial is in black. It's technically black here, or black on the green channel. Let's go to the green channel here and look, and we can see on the green channel this is actually void. We have black here. So as we switch this between values from when we're at 0, that's weird. Yeah, no, oh no, that's right. I was just having an optical illusion. So as we can see, when we move it positive on the green value to 0.5, we've moved it so that the center is white. Okay, when we take it down to 0, it's perfect 50% gray, and when we take it to -5, it's black. All right. So what that means is that in order to make things move towards the top on green, in our eye distort, we have, if it has to move up, black has to be at the top of, at the highest point of our values. All right. Well, if we look at our SEEXPR node, we can see that we're actually doing the opposite of this. We have whitest value is up at the top, and the blackest value is at the bottom. So what's happening right now is we're actually pushing away from the center point, which is not what I think we want. I don't think, actually, is it pushing or is it pulling? I don't know. I think it's pulling, if we were to do this. All right, let's get off of this and go back to our, go back here, connect this up, and just for a minute, let's go get off of green up here so that, whoops, there we go. So that we're looking here and we go back here. So what it's doing is, even though I believe this is a white value, this is a positive value here. Notice this is positive. Even though this is positive. Oh, yes, this is another thing we should point out. Let's see if this is going to show it. Well, it's not going to show it yet because we haven't done the one other thing that we need to do, which is this is not showing our transition. We don't have that shape. It's just the solid shape of the ROD of our radio. So we need to take what the source alpha of this, our alpha channel from here, and let's take a look at that. If I hit A here, so we're looking at the alpha, we can see off our radio, the alpha channel is a radio. But if we go over to our SEEXPR, right now our alpha is a solid white square. And that is because we've told it we want it to be 1. If we set it to 0, it becomes black. All right. So how do we, the way we get the alpha channel from input number 1 is we tell it that we want the alpha from source A, and then we put in over here basically A channel for A for or color the alpha of, and then we tell it the input. And technically for A1 we don't actually enter anything. It actually, the source one, A1 would actually be the second channel. The first one is 0, but we don't have to enter it. We just have to say AS. All right. And so when I hit AS and I hit return, whoops, I don't return. Excuse me. I click off of it. Now we can see that I've pulled the alpha of that source. So when I go take this off and I go from the alpha channel up here back to this, we can see right now it doesn't look like it's done anything. But when we merge it over this other one, we do have a problem here. This is not what I had the other day. Oi, this is not. I'm getting a different result. Oh my goodness. Sometimes I swear Natron wants to make me... I'll get so angry and upset with Natron. This should not be giving us... You know what it might be? I've got an idea. Hold on. I think what we may have to do is, I think in the merge node, I think I set it to screen. Is it screen? No, not screen. Let's put that back to over. All right, what's happening is that our merge node is not doing what I want. I'm going to just double check my source. I think there is a way we can change this. What the problem is it's not recognizing this as a let me just see. It's not what. All right, so people are aware. What it's doing is it's treating it as an unpremultiplied alpha channel, or a straight alpha channel. And so what's happening, it's expecting it to be pre-multiplied, and it's doing all the pre-multiplication to what's existing there. So what we need to do here, I think right here, to fix this, we could fix this with a, if I tell it that this is a, let's see, I think if I tell it, no, that's not what I want. I think I need to tell it that, all right, maybe I'll need to tell it but we shouldn't need this, I think. Oh no, it's still doing it. All right, let's see. That is definitely strange. I'm getting a definite weird output. You know what? Maybe we need to feed it the mask. No, because now when we feed it the mask, all right, that's fine. Whatever. We can fix this. There's another way we could fix this. We could set this back to 1, and we could. No, now it's treating it. All right. Now it's treating it wrong in that way. I swear, sometimes. Let me give it one more thing. Let me try unpremultiplying this like that. Nope. It's pre-multiplied. All right. Sometimes. Maybe it's on. Let's try. I shouldn't have undone that. Well, I'm going to try 2 more things. I'm going to try an unpremultiply that. Nope, that's not working. This is just doing the wrong thing. This is very, very frustrating. I feel like there should be an option in here to tell it that it isn't pre-multiplied. Let me just double check my original thing. See, one of the things I did in the original one was I ran it into a group node, and I don't know if the group node itself is causing. Let me just check inside. If I go inside of the group node, Huh. Sorry, everybody. I'm just looking through making sure my sources are right. I want to check inside of this one. This one's right. All right, let's look at that. It's AS. Yeah, let's just see something here. I'm going to try something really weird. That shouldn't, in theory, do anything to this. If we tell it that, all right, let's tell it that it has no source. Let me just double check here. Make sure that, does that have a source? No, it's none. No, that's right. All right. So, right, let's just try and group, no, not group. If we group this so that, that's weird. That's not what I wanted. Let's try that again. I didn't want to group that. I want to group this. Group. Why is that EXPR? Control X. Go into the group. I swear, sometimes. No. Alright, 1 second. Boom. Let's delete that. Oh, I did the wrong thing. Try this one more time. Group. Group that node. It's not putting the node in here. That's alright. We can manually do this. Grab this, copy it. Natron's doing its own wonkiness here. As we know, just because this always irritates me, we gotta do it. We just gotta do it. There you go, Natron. You deserve that. Because you shouldn't be doing this. Alright. Let's just see if this works. Alright. This fixed it, or this is how it's working in the other one. I put it inside of a group that I had named. When I did it that way, it gives it there. Let's see if we have it in group 2. We put that there. It's not looking like it's doing something different. Let me just check something here. All right. Where the heck? All right, we need to close that. Close that. There's my node graph over there. Oh yeah. Let me just look at that. On there. What's going on there? That's looking right. Screen. You know what? I wonder if it's because I did plus. Maybe it's because I did plus. No, it's still doing the wrong thing. Plus there. Oh. In the original version, I was hoping to avoid something that I had done before. All right, we're going to just delete this. If it does this, there is a way around this. And it's annoying, and I don't know why it's doing it right now. What we can do is break this off beforehand and go around it. Let's change this back from a plus. Basically, Natron is not, for some reason, by default, accepting the SEXPR nodes input correctly, or output, I should say. It's not merging it correctly. Let me just put this from plus back to over. There. So what we're going to do is we're going to merge this afterwards, and what we're going to do is pull the mask. We're going to set this so that it's the B channel is empty. We're going to set the A channel to be our object, and then what we're going to do is route, just so we see the mask up there, so it bypasses it. All right, and this always works. This is the old reliable way. It's annoying though, because this, you shouldn't need to do this in order to get this to function, and this was one of the reasons that this worked inside of my thing, and it works. I've broken it apart. I have it over here. I'll show you. Hold on 1 second. Let me I just have to edit ungroup this. Where's the ungroup? Expand group. There we go. Now it should be, this is going to look a little weird, but all right, I'm going to go over here, there. Let me, I just want to pull this up so that it's the exact same. set that to over, get that out, so. Huh. Oh, right, there is one other thing we haven't done yet, which is we haven't actually done. All right, there is one other thing I want to do first, which is I want to go back here and just talk about this. How do we reverse this? All right, because as we can see, the black is in the bottom left, which means if we go into the green, let's just go into the green for right now. Black is in the bottom, we want it to be at the top. Well, what we have to do is basically, instead of working from 0, saying we want you going from 0 to 1, we want to take 1 and which is the maximum, and subtract u from it. So we say 1 minus u, or actually, well, in this case, because we're looking at the V channel, let's do 1 minus V to see what that does. So if I go 1 minus V, I'm going to invert this, all right? And now it goes from 0 to 1 in the opposite direction. Likewise, if we go over to our red channel here, as we can see, it goes from left to right, and left is, we need black to be on the opposite side, so we need to go from 1 to 0, or from 0 to 1, 1 to 0 is technically what it's doing. So now if we go out of our red channel here, we can see that we've basically inverted it. All right, so that basically reverses it, so we wind up with this, and I'm getting a different result. I'm getting a very, very different result. I think I'm getting a very different result. I want to just check something here. All right, that's right. What is my radial set to here? I just want to make sure I've got the values set up correctly. Sizes? That's very weird. Let me just see something here. Alpha? Oh, is this working? No? Wait a minute. Yeah. Oi. Alright, so I want to just bring this up here. This is my reference, and this is just rearranged so that I can see it easier. So here's our radial here. This is what I had for my SE expression. Let me just make this for OBS capture. All right, so here's our expression here for our SE expression node. We can see the two things, and that's all we've done over here. And we can see down. Oh, I'm probably covering this up in the corner. Ugh. This is annoying. I'm pulling this over, so hopefully, yeah, there we go. All right, we can see it now. So here we go. We can see, all right, let me, B is over. Let's just take this out and put it in A. There we go. So if we look at here at 1, we can see here it is. It's solid. We've got it in. We have exactly what I wrote. Here's our radial. I'm doing this just to show you guys that this functions in here. We have this set correctly. This is it's not set to reformat. We're going 0 to 1. We have it set to 1. It's mixed as 1. Okay. Oh, but the difference is up here. We have it set to we have this set. The scalar parameters are zeroed. Everything's right. It's 1 minus u, 1 minus v, and as. So if anybody had been copying this in and didn't work, I apologize. This worked. Or I swear, you know, this is one of those things. It's like, why, Natron? Why are you working in one situation and not in another? There's no reason. We have this exact same thing. There's nothing else we've changed here. We have AS, UV0 on this. We go to a merge node. When we merge it over, all right, the solid is set to 1 as opposed to, let's set this to 0.5. There we go. Wait a minute. Why? Yeah, that should be 0.5. That's interesting. Huh. I see EXPR. Well, that's solid. is 1. Merge over alpha. Maybe it's no. Fascinating. This radio, it's outputting an alpha. Is this? That's weird. Let me just check something here. Alpha's 1. All right, here. Whoa. Whoops. Oh, I didn't want to do that. I want to keep that at 1. Whoops. Let's go to the alpha here. No, it's still that. And we go here. 1. And we say, now the alpha is 0. Interesting. Huh. But here we got... Let's go back to ours. I'm just going to minimize this. Sorry, we're troubleshooting right now because this is... I'm not doing what I was expecting. See, here we have we're getting a gray output, which is what I'm expecting we should be getting from the other. The other one was set to... Let me just verify that this is set to over. Union. No alpha. Maybe it's because... is alpha masking unchecked in this? No, it's all the same. No. I really cannot tell you why this is everything is exactly the same between these. They should give us exactly the same results. Anyhow, all right, because of this, I might actually redistribute this. If you want to build this on your own, and it does do this weirdness that we're getting here, as opposed to working the way I had in the other one. Build it this way, bypass it, just pipe the mask, basically, or pipe the SEEXPR into here, like so. I will distribute this as a thing, because this will work all the time, and I'd rather have this work. So, all right. Anyway, now you know how to build it. This is all there is in the original node. I swear. Well, anyway, all right. So what does this do when we get over to our iDistort? What's the difference? We've spent so much time on this. I don't really feel like we've spent time talking, evaluating what it's doing. Let's look at the difference first of all. Here is. Let's go back to our ad. All right. Let's first of all set this so that instead of our radial over here being set to. Well, let's see. Let's reset this to default, all dimensions, so that it is set to a value of 1. All right. This is what this radial over here is set to. All right. This is for our warp field. All right. Here, let's just verify. I want to make sure. All right, that does it. Oh, the reason it's set to color RGB versus none here is because this is. Let's see if we just reset to default. Yeah, it just disappears. It's because this one here, we're feeding it a solid for the background because our field is set up beforehand versus in this version, in the new version, we're setting it up afterwards. We're compositing the results over it because we have to retain. We don't want to change it afterwards. This one we're working in black and white. This one we're dealing with colors. So we have to do the composite of the gray afterwards. All right. So, but all right. This is 1. This is a set. This is add set to or the radial set to 1. All right. On this one, if we take it and just pipe it in and look at it, let's first of all look at the differences. This is what one looks like. This is what the other one looks like. We can see this one has black and white. This one has color. It has the UV map, and the UV map is of course our UV map set to the dimensions of our. Is this UV map set to the dimensions of our things, but in reverse so that it works? All right. So we wind up with this. All right. So back here, what the colored one does, or the grayscale one does, is that because it's uniform, it's equal amounts of both red and green to 1, which is basically 1.5 times movement, it's pushed it down towards the bottom left. Positive values move it down towards UV00. All right. Over here in this version, we have something very, very different. Well, you can see that everything sort of is pushing away from, scaling away from the center point of our radial. All right. So we go over to our radial here. If I double click on this and I say, and I take this and I watch what happens. This is the interesting thing about, or the cool part about this, is if we take our value, we don't even have to change the colors. All we have to do is change how much we're applying the mask. All right. If we increase our mask, we can see the magnet increases. It's pushing away from, or it's distorting away from this point as we increase it. And if we pull it in the opposite direction, it pulls it towards it. So it creates kind of a vortex towards that point. And this is magnetic. This is basically a magnetic point. All right. And we can see it, and we can see the difference between the two. All right. So when we set this to a value of 1, so that it's pure white, we can see that it has distorted it. We're using the exact same settings. This is what a value of a 1 on our solid gives us with warp field. It warps everything linearly away from, it pulls it from one side and pushes it towards the other side. So it's pulling here from this point to this point, and it's pushing from here to here, which causes compression. This is undistorted. This is, it would be, if it was zeroed. So what happens if we smooth out our, whoops, wait a minute, what's going on here? Solid, oh, that's the wrong thing. I wanted the radial, not the solid. If we reduce our, this solid, if we take it down so that the smoothness is halfway, we can see it's still pulling as it gets towards there. Then it has a zone of perfect space, and then it distorts away from it down, and then it eventually straight levels out. So it smoothly distorts through. All right, let's go back to the other and look at what that does if we do the same thing. All right, this is just important to understand when we're dealing with this. So if we take our smoothness here, we can see as we lower it, we're winding up with a much more desirable result. We're winding up with something that's distorting around our shape, and we wind up with this kind of bowl almost shape that represents our circle. And when we pull this around, it's much more pleasing to the eye, and it's much more in tune with something that might be useful for shape distortion. So if you were to do something that needed to retain, like for example, if you used a rotoscope, this type of distortion, if set up correctly, could in theory bend, for example, an arm, like in our character animation. And I might demonstrate this on Saturday some more, because we've run pretty long, or we've gotten up to the 45-minute line. We've gotten into here, and we haven't done the, I'm going to show one more thing, which is before we go, I'm going to set this back to 1, and I want to just show a really interesting other thing that we can do here, which is I just want to where's my other one? I want to bring this up, and I want to talk about a different type of thing where we switch. Just want to make sure something. This should be set to plus. Oh, foo! I've got this all wronked out. All right. So what we want to do is this right here. This whole unit here would be considered our magnet. All right. Let's make a backdrop. So backdrop, and let's call this backdrop magnet. Just so we're clear what this is, and let's give it a color so it's nice and easy to see. We'll make it this sort of I don't like that. I think that's going to be hard to read potentially. Let's put this here and pull it around. So this is a magnet. this is one whole magnetic unit. It consists of a whereas this is a whole warp field. This isn't the warp field. This is the warp fields are the magnets in the warp fields are really just the radial, whereas this is the warping device inside of this, and our entire this is basically the equivalent of this. So it consists of more components to make it do the thing that we want to do. So, but we ultimately, if we want to make another one, all we have to do is copy our magnet and then pipe our magnet in to our over node, and everything just basically goes in over our over this. And we actually, what we really want to do is, instead of saying over, we want to say screen. All right, and the reason that we want to screen it is because what we really want to do is we want to okay, we're seeing, I think it's screen. Hold on one second, let me make sure of this. Oh, right, not screen. Well, it doesn't matter. This is a two-part thing. We want to either screen or we want to plus here. But the problem we have is it's adding to this solid. We need this. We don't want those adding to our solid. We want those to add with or one another or work within one another. So we want to isolate this node here from this node. So what we're going to do is right here is we're going to add another merge node here, and we're going to remove the solid. All right, so that this goes in, and we're going to take it and we're going to tell it the result of all of these nodes added together or whatever that give us, or screened together. It can either be added or they can be screened. Screen will basically keep them between 0 and 1, I believe, whereas add will add the two together, so you wind up with values so they can basically influence more. But we want to keep our baseline. We want to have the things happen relative so that they still go to black. We want it to pivot around that, which is why we need to separate it. So we pipe that in to here like so, and when we go in like this, we wind up with, we don't wind up with what I wanted. Why am I getting, now I'm getting another thing that's off. Why is that doing that? Oh, this is set to screen, not over. This should be over. Wait a minute. Oh, and it doesn't have an alpha. There we go. So we need to make sure that the solid channel is producing an alpha so that it goes into here. All right, so there we go. This has an alpha coming into it, and so what we wind up with is this, and we can see, I just want to point at the two magnets. All right, we pull this alpha off to the side, and we see we have two magnets here. All right, so they feed into one another, and we can see that they can individually be controlled by increasing their values and so forth. And the one thing that we can do here that we couldn't do with the other one is this is another really kind of interesting thing, which is if we take our solid and if we put this up here to the UV to the plus, we can see we wind up with the result that we don't want. And then we set the B to the background. All right, but we change the background from being solid to being now we're getting a totally different result. When I got something very, very, very different than this. Sometimes I swear Natron just doesn't want to work. All right, skip that. There is no such thing as, I don't know why that's not working. Oh, well, let me just see something one more time. I feel like we're getting, why is that not working? That was doing something very, very different than what we're getting now. I can't tell you why that's happening. We're not going to talk about... shoot, that was really... That was one of the coolest things, was I got this very interesting thing. Well, anyway, this was the original point, was to make... I'm a little bit disappointed in this. All right, well, the cool part about this is we have magnetic fields, or magnetic distortion, that we can control, and we could use, just so you know, all right, the one other thing I'm going to talk about in this that doesn't work, we're going to put a roto in here just for a quick second. ROTO, pop in a roto, just put in a random roto shape. So this also works with roto nodes. So here's a roto node. We're going to just draw in a whoops, or didn't want to do a... I think we're going to make a random shape like this, then like that, and then like this, and then like that, and then like that, like that, and there. Now, and we of course have to make it so that it's solid. Now you can pull on these things or adjust the softness and so forth, but honestly, to get the best results out of a roto shape, here, let's pop into this and go back to our eye distort, and we'll just pull this out. So we're looking at just this. One of the problems that we face is that this is currently all right. So this has no, this is not affecting. There's no alpha channel here, so there's no way we can scale this up. So what we have to do, one of the things we have to do, is we have to add a shuffle node after this. So we're going to go here, and I'm just going to show you how to get the rotos to work with this. So we go, we'll put in a shuffle. All right, and for the shuffle, all we do is we set everything to the B. Because it's going into the B, I set it so that it all goes to just a single red channel. So I want everything to be it, because this is only going to be, we only want this to be the shape in all the channels. Doesn't matter, we're only dealing with value information, just like we did with the radial. The radial's only dealing with black and white, all right? But we want to blur this, so we want to go here and we want to take the end result of this and we want to blur it so that it's smooth. If we do that, you can, as I say, adjust the Bezier shape here if you want, but you can't ever make it really go eat into the shape, which might be a desirable thing. And I want to demonstrate that first. So we're going to do a blur by hitting B to get our blur up. Let's go back and let's look at what that's going to look like. So here in our blur, if we take our blur way up to a really large number, so that it does something like 100, or even in our case, we're going to go up to 200. Just to play, we'll play with it. So this is that valued to 200. If I go to my eye distort, what is going on here? Something is weird. Hold on. Why am I not getting? Oh, we're looking at the alpha channel. That's why. All right, there we go. We go back to the eye distort. There we go. So, all right, 200's a wee bit much, but in the case of a roto, it's controlled by a couple things. We can increase the value by basically taking up. What the heck? Why is that not? Oh, Bezier one. All right, but you select your Bezier shape that creates it. You can set your value up by increasing this. Determines how much it's distorting. And then, of course, it makes the shape to, this is what the UV map for this is, all right? And then it converts it down to that, then it superimposes it, and this is what it looks like superimposed. And then we go on to our distort, and the blur node, what the blur node does is it determines how it transitions, the smoothness of how this transitions from the one shape to the other. So you could use this to... you can see that by reducing this, we can make it harder transition a lot more steeply, or by increasing this a lot, we can distort it a lot, or so that it's nice and subtle, and you can make shapes and so forth. And just so you know, we can also plateau this if by, again, let's disable the blur, and instead of the blur, let's go back to our roto node here. And I'm doing this as a secondary thing because I want to point out that this is what, if you want to do some interesting shape retention type stuff, or weird shape retention stuff, you can do it by pulling on these here and just reshaping, you know, your whole, how it's transitioning and whatnot. All right, so this is, as we can see by doing that, there's the end of that. There we go. Pull that in a little bit. So we can see that I've made it a little bit. Let's turn off that so we can see the shape. And this doesn't look particularly right because again, it's too harsh. We obviously want to have a little bit of a softness on the edge, probably. If we were, well, anyway, let's take this down. Let's take our blur down a lot. Oh wait, we want to not take it down yet. Hold on, whoops. We want to activate it. There we go. We've reduced it, and we can see we can do really interesting stuff where we deform it and get it to pull in more distorted or less distorted ways, and we can create really interesting shapes with this. And if we were to, we could use this to, we can do shape maps and stuff, and I will get into doing how this can be beneficial in another way in another tutorial. And we're going to call it at this point. This is way longer than I had expected this to be today, but I do want to also point out that you can add the shapes together, and you can pull these around. Our roto shape, if we go to our roto, we can select our entire roto as an entire thing and pull the node around as well and animate that. Or we could just, an easier thing might be to just take and put a transform after it and use a transform to transform the roto, which gets it a wee bit wonky. You can see it's weird, but it functions. And it's just giving us an that's just because it's not keeping up with the live interaction for some reason. Anyway, that's all I wanted to talk about today. I don't know, a lot longer than I had expected. So this is roto shapes, or excuse me, roto shapes. No, this isn't roto shapes. This is magnetic field distortion versus warp field distortion. And as you can probably tell, it could be a lot more useful for shape retention and doing interesting things with your shapes beforehand. And there's all kinds of ways. You can invert your nodes and stuff to make them, you know, go from black to white, which will make it distort in the opposite direction. And anyway, enough said. You could, yeah, I don't want to get into too much. I'm definitely going way overhead. But this could be used for more interesting things. So I'm going to call it there. All right, thanks for watching, and keep on Natroning.